Well, hello everyone. I'm glad you're here. I am excited about this project we're tackling today. We're going to learn some great Excel formulas and put them together in a creative way to create a powerful tool. Now, if you haven't come directly from the previous video, part A, I recommend that you go and watch that. It really sets up this video. It gives you a high-level overview of the issue that we're trying to tackle. Basically, we're trying to make sure that we maximize our investment dollars and we don't have any lazy money. We want to fully participate in the market and get our money working for us as hard as possible, as soon as possible. So check out that video, then come back to this one. Now that you have a high-level introduction of what we're trying to accomplish, in this video, we're actually going to build the Excel investment allocation tool from scratch. We're going to go step by step to make sure you have a working copy by the very end of it. I want to give credit to Excel Off the Grid for his creative and elegant solution for dependent drop-down lists. There's lots of videos out there that I saw regarding this particular subject that were complex, but this solution was quite elegant, and I integrated it into this model. I hope you appreciate and enjoy it as much as I did. Okay, let's continue. So in sheet number 1, I'm going to put in, this is we're looking for the category. We'll say ETF name, ETF symbol, the lower boundary, and upper boundary. I'll just size this up appropriately, and this ETF name will be bigger, so I'll just expand that a little bit. So our first category will be a core holdings, sorry. Whoop, there we go. And for our first core holdings, let's use Vanguard's VOO, VOO, which is the S&P 500. The ETF symbol, we'll leave it. In the lower boundary, we'll say 40%. Between 40% and the upper boundary is 60%. So for core holdings, since it's foundational to our portfolio, I want the total amount within that category to be between 40% and 60%. So that 40% and 60% will remain stable for all the ETFs within the core holdings. So I'm going to go ahead and input some of the ETFs. Then we'll come back. I have the ETF names here, and in order to get the ETF symbol, you might be wondering, well, isn't this redundant? Why is this the name? It's not truly the name, but it's really the symbol. So here's why. To be able to pull things dynamically, and for referenced in the model worksheet, I'm going to convert this data type into stocks. So right now, just the names. So from here, under the ribbons, we'll go to Data. Under the data types, I want you to click on Stocks. So what this does, Excel automatically recognizes this symbol name, and once it does that, we can pull a lot of information about a particular asset. You'll notice here in the top right-hand corner, little button is Insert Data. If we click onto it, we can grab a lot of information. 52-week high, low, the beta, the change percent, exchange, expense ratios, instrument type, a lot of interesting things. We're going to pull the ticker symbol. And right beside the next free cell over to the right-hand side, it'll input the data that we're looking for, we requested from the insert data. Great. Now we'll put in, dividends. It's a dividend category. And the first one, we'll do the ever so famous SCHD, hit enter. And as soon as, gotta change that, that's the wrong one. So this is a great lesson. We put in SCHD, and Excel assumed this is the asset that we're looking at, which is incorrect. Let's go ahead and change what it's referencing. So we'll do a smart lookup. I'm going to change this. I'm going to delete and type in SCHD. Now hit enter. So what Excel is going to do is going to search for different symbols that are SCHD that are relevant. So from here, we can take a look at the one that we want. And it put in, notice the second one. the Shearders, Van Kovich's, I'm going to screw this up. Let's go to the proper one, which is just above it. This is the Schwab US dividend. Yes, this is the one that we want. So we'll choose insert data type. Perfect. That's the one we want. All right, we'll go ahead and insert the other dividend ETFs. And finally, we'll put in the growth category. And I'll convert these into the data type of stocks. And I'll select all of them and insert the symbol. And now we'll just do the boundaries to the appropriate categories. So between 40 to 60% will be for core holdings, 20% to 30%, that'll be for everything else. Great. So now what I'm going to do is I'm going to convert this into a table. You can do it multiple ways. Either you can press Control-T to bring up the table menu, or you can also go on your menu, Insert, Table, make sure the My Table has headers checkmark boxes there, hit OK, and now it's converted over. The great thing about this is that if I add other categories or even other assets, the table will automatically update. So, for example, one that I forgot is none. Whoops. So for none, this will act as a placeholder where we're not choosing ETFs within our model. Notice here that it got a field message saying it doesn't recognize, there's nothing in here, and Excel's trying to pull the ticker symbol for the asset that's blank, and we're not going to put anything. So instead of having this error message, I'm going to change the formula here. So currently it's pulling the ticker symbol for the data type of stocks in cell C2. So if this returns an error, I just want a blank. So let me just change this. I'll go to the top, and once I do it at the top, it'll flow through the remainder of the rows. Error. Now, if this resulted in an error, I'll just tell it to put a blank space. Not even a space, just blank, leave it blank. And we represent that by 2 quotation marks. Close bracket, and you'll notice that it'll update, and there we have it. It's been fixed. So what I'm going to do now is create the dynamic ranges. In order to do this, to be used with our data validation lists, this has to be sorted. Now, you may not choose to sort this table, or it may come to you completely unsorted. Not to worry, when we create these helper lookup columns, we'll do it within that. To build this part, we'll do it right beside here in this table. So the first column name is category, and we'll choose ETF. I'll do this a little bit backwards. Symbol, ETF name, and here I'll make my life easier. I'll copy these and place them over here. I like that formatting, so I'm going to apply it to the other cells. So in order to do that, I'm clicking the cell in K1. It's got the formatting. I'll go here into the home, and on the clipboard, I'll press the format painter once, and now just select the cells where I want that formatting to be also applied. Great. And I'll make this a little bit bigger. I'll have to adjust it shortly because the ETF name will expand past the borders here, the column width within column J. So let's begin building our dynamic ranges. So for the first column here, we want to pull all the categories into one column. So we'll begin with equals. And we're going to do the choose columns. And what's the array? Well, before I tell it what's the array, we have to sort it. So now I'll type in sort, open bracket. Now, the array is the range of data. So we're going to choose the entire table, but then we'll tell it what column we want to pull. So from here, I'm going to go over to the top left-hand corner of the table. And as I hope you're following my cursor right now, to select the entire table, I'm just going to go to the top left-hand corner of the table, and you'll notice the arrow changes into a diagonal black arrow point going from the top left to the bottom right. I click onto it, it selects the entire table. Wonderful. And we can see it here, see the little symbol, table 1. Great. And now we'll tell it how we're going to sort it. We're going to be sorting it by, first I'll include all the columns. 1, 2, 3, 4, 5. I'm going to close the little curly brackets, which is telling you what to include within this sort. And close that bracket. And for the columns, we're going to tell it just to choose the first column. Close that bracket. And now we have all the categories sorted. You notice the first one says none, and that was the last row within our table. So now that's sorted. Now we're going to do the same thing for the ETF symbols. In fact, what I can do is I'm just going to click and drag this over, and we'll fix them appropriately. The ETF symbols, this happens to be within the third column. The name, whoops, this happens to be within the second column. So I'm just changing the very last number to indicate what column we're pulling. And the lower boundary, that's within the fourth. And the upper boundary within the fifth. And I'll just change these to % style. Wonderful. So now that I have this built, I've got my listings here, all the different ETFs that we can add to, then this table will automatically be updated, and we're going to be using this in order to create the validated data. Let's change the name of this sheet. It's currently says sheet 1. I'm going to double click and call it assets. Hit enter. Now let's create a new sheet where we'll build our model. Click the little plus sign, and we'll call this allocation purchases. Hit enter. And I'm going to make this just a little bit bigger. I'm going to zoom in, bring it to 130% so it's a bit easier to see. Let's begin. It's a bit narrower, and I'll call this, the title is Money Allocation. Whoops. Try spelling it. There we go. Allocation. Oh, for asset purchases. Enter. Wonderful. Then we'll have some key statistics up here. The first one will be, or information, total amount to invest today. And we'll have funds remaining. And I'll make this both accounting style. Let's say we have $1,000. There we go. Whoops, we'll just put this as a placeholder. All right, so I'll begin building this by putting out the column headings. Let's type those out. And we'll speed through this part. Join you once I'm done. Okay, the headings are done. Let's start building it out. A couple of things I'm just going to change here. I'm going to select everything and size it up a little bit. I'll have to do it again a little bit later once we have data in there. All right, let's start off here on the left-hand side. So we'll have room for purchase of 10 assets at one time. So I can put in, start creating a list 1, 2, 3. Alternatively, what I'd like to do is using the sequence function. We'll do 10 rows, 1 column, start on 1, and step of 1 as well. This is a quick way of putting down a list. There's lots of benefits behind it. I won't get into it right now, but nice, quick, and easy than typing in one after the other. All right, now for the category. This is where we're going to build our validated list. So in order to do this, we are going to go to Data, and under Data, Data Tools, the icon right here is Data Lists. So from the section criteria, Allow, we're going to choose a list, and the source, we're going to use a formula, equals. We'll go to Assets, and this is where we're going to use, we need to use dynamic ranges, specifically in order to build these lists. So we have assets in H2, and I'm going to put the hash symbol, so it selects all the rows within that column. Now, the great thing about this, it'll only choose unique values. So hit enter. Now from the drop-down list, you can see we have the 4 different categories. Wonderful. Now asset symbol. The asset symbol, when we build a validated list for this, we want it to be dependent upon what has been chosen here. We don't want a list of all ETFs, only the ETFs within the category that we've designated. So that's the next step. So we're going to choose, I'll just choose one core holding in the meantime. Now let's go ahead and build this list. I'm going to create the formula here, but once we understand the formula and we have it, then I'll copy it and I'll put it into a validated list. But we'll just use this now for building to make sure we understand it. So we're going to have to build this formula in a few steps. Let's begin with the take. So take, what's the array? Well, we'll go back to assets. We want to retrieve all the ETF symbols. So we'll also lock that in with an F4 and a hashtag. Now I tell it, well, how many rows do I want? So if I put in something random like a 5, it'll take the first 5 rows. So in this case, it'll start off with the blank and the next 4 ETFs. Let's see what happens. And indeed, that's exactly what it returns. So we don't want just a random number 5, we want a dynamic. So let's change the 5 to a XMATCH. So what are we going to match up? We're going to match the term core holding, comma, where we're going to look at it. Well, we're going to find it here within this column H, but don't forget, I'll lock that in with an F4 as well as a hashtag. Match mode will be exact. Now, if I close this bracket, it's going to look for core holding. It's going to find on row number 2 relative to the range, and it's going to return the first 2 elements from the ETF symbols. So one's going to be blank, and the other one will be XLG. Okay, so this isn't exactly what we want. We want all of the ETFs associated with core holding. So we have to approach the formula a little differently. The XMATCH. It's starting to look from the top down, but we actually want it to go from the bottom up. So it'll take the first number of rows where it matches the last term within that category. So the match mode with 0. So for the exact match, now I'll press comma. We're going to ask it to search from last to first. Now let's hit enter. Perfect. So now we have the list of ETFs. We still have that blank. But for core holding, let's go back and take a look at it. The last core holding ETF is VTI, exactly what we want. So we have to get rid of that first row. So we're going to introduce another formula. So we're going to wrap this up inside of a drop formula. A drop formula just gets rid of unwanted data. So in this case, unwanted rows. So after the equal sign, go for drop, open bracket. So we have the array here. Now for the number of rows, we have to do another XMATCH. So we're going to find the first instance of core holding. So we know in our assets, it's going to fall in row number 2, or the second row. But the second row will contain a ETF associated with core holding, so we want one less than that. So sounds like a lot. Let's go through it. Comma, how many rows? We'll do another XMATCH. We're going to look up the term core holding, comma, where we're going to find it, go back to assets, find it here in core holding, function, F4, sorry, and then a hashtag. Comma, the match mode is going to be an exact match, comma, I'll actually just close the bracket here. Now, if I just close it, let's see what we get here. It starts with IVV. Double check. So if it returns the second row, so it's going to drop the first 2, but we need that XLG. So let's go back. What we're going to do here is once we've found the XMATCH, so it's going to be in this case for the core holdings to row number 2, we want to subtract a 1. So it'll only drop the first row. That's much better. Now we have XLG, which is our first asset for core holding. Yes, it is. Great. Now that we have this formula, we can take this formula and put it inside of a data validation cell. So I'm just going to copy the formula, hit enter. Now we'll go under the Data tab, Data Validation Tools. I'll choose Allow Any Value, change that to List, and paste the formula. Hit OK. And now, if I choose, I can choose whichever ETF that I want. So let's change it up here. Core holding, we'll go to dividend. Now from dividends, let's see what ETFs are available. And we have them listed here. Perfect. We'll go back to now, let's choose growth. Then I go to asset symbol, and I choose the different ETFs specifically related to growth. Perfect. Now for symbol name, what we're going to use is an XLOOKUP equals XLOOKUP. We'll look for the asset symbol, comma, where we're going to find it. We'll find it back in the assets. And the dynamic range, I'll F4 it, as well as the hash symbol. And the return array will be in H2. I'll lock it in with a F4 and a hash symbol. If not found, we'll return a blank, and match mode is going to be exact. Oh, symbol name, I made a mistake here. I don't want the category, I wanted the symbol name. Let's see where that is. Oh, that's actually in J, so we'll fix up that formula. We want to return J. Much better. All right, we're making some good progress. So now, minimum allocation. We want to look at the category and return the percent allocation associated with that category. So the growth, that'd be, we have 40%. Oh, that seems a little odd. Oh, let me just double check here. My core holdings, 40, 40, 40, dividends, 20. Oh, looks like the data was not correct. Here we go. Perfect. Minimum allocation. So for QQQM, minimum allocation would be 20%. All right, let's go back here, and we're going to do an XLOOKUP equals. Let's look up the symbol name, comma, where we're going to find it. We'll go back to our assets, and I'll do F4, lock it in, as well with a hashtag so it goes through the entire dynamic range. Return array will be for the lower boundary, F4, hashtag, and if not found, we'll just do a blank. Match mode will be an exact match, close bracket. And we get 20%. You may have to change this to percent sign if it comes out as a decimal. Now, before we go over to the max allocation, there's a caveat here. If I wanted to have, say, 2 ETFs within the growth section, I don't want each ETF to have an allocation of 20%. I want to divide it between the two. So we have to change our formula ever so slightly, and we're going to use a COUNTIFs. But before we get there, oh, I didn't copy this all the way down. And I'm going to just choose for now none. I'll recopy it and paste. And we have blank. Oh, I don't know if I do the data validation, copy, and I'll just paste it here. And we'll choose blank, and then we'll copy it and apply it to the rest of the cells. Great. So let's say I wanted to have another growth. And this time we'll choose, let's see, VUG. Perfect. I'll copy this down too. Great. Now, if I just copy this, it says 20%, but we don't want that. We want 10% because we have 2 ETFs. So let's change this up here. We're going to do the XLOOKUP, which is exactly what we want. Then we'll say divided by COUNTIF. Whoops. What's the range? Well, let's take a look here. The range is, we'll look for growth category, And I'll lock that in with an F4, comma, what's the criteria? That's the category here in the first cell, close bracket, and we get 10% because there are two growths. So let's copy this down. Perfect. So we're going to do the same thing for the max allocation as well too. We'll do equals XLOOKUP. We're going to look up the asset symbol, comma, we're going to find it. We'll go back to the assets. Here, we'll lock it with F4 and a hash symbol, comma, return array. It's the upper boundary. Lock it with an F4, hash symbol. If not found, we'll just do two quotation marks, and the match mode is going to be exact. Great, now it pulls it up. Oh, here's where we have to change it to %style. But again, we want to do the exact same thing. So let's fix this, divided by COUNTIF. The range, here's the range, lock it in with an F4, comma, and again, for overall for the category. Close bracket. And now we have 15%. Perfect. Exactly what we're looking for. Here, let me just copy this all the way down now. Let's copy this, and for all cells, and I'll just paste the formula. And don't need this, so I'll choose that. And indeed, it gets rid of it, but we have some zeros here. We'll fix that in a second. Excellent. So even though we have here, if it doesn't find it, it'll return a blank. But because we're looking at dynamic ranges, anything, even though it's blank, it's going to return a 0. So let's change this up a little bit. So in this case, I'm going to wrap this up into equals if. If this formula results in a 0, comma, we'll leave it as a blank. Otherwise, we'll go ahead and just do the XLOOKUP. And we'll close the bracket for the if statement. And I'll copy this down. Great, it just cleaned it up a little bit. Just looks nicer as opposed to having the different zeros. We don't need to take up the space. Let's not do it. Now I'll tackle the actual split. The actual split is the total value, so the market value, divided by the total amount that we plan on investing. So we'll lock that in with an F4. And we have 0. Perfect. So the test split, these cells here are required by Solver in order to find out the optimal splits. So in this case, I'm just going to put in right now, call it 30%, just to take up space here, because for the current price, we're going to derive that from the fact that the data in here is related to stocks. We'll click here and insert data, and we'll choose price. Wonderful. Now for the units, we'll take equals the total amount multiplied by, oops, I forgot to lock that in by F4. There we go, multiplied by the test split, divided by the current price. Now this gives us a fractional share. So 1.43, and our broker doesn't allow fractional shares. So we'll have to use the truncate function, equals trunc, open bracket. So we want this down to 0 decimal places. So we can purchase 1 unit. And the market value for 1 unit is take 1 multiplied by the current price. We have a total of $209.80. And for the funds remaining, we'll take the amount we're investing today, subtract by the market value, $720. And I'll just complete it for this row, this column, minus the market value. I'll drag it all the way down. Wonderful. Now, just a quick note here. You'll notice something here. For the growth category, we're allocating between 10% and 15%. We have an actual split of 21, so much greater than what we're allowed because it exceeds the max allocation. So we have to change this for a couple of things. Number one, I'm going to change the category. I'm just going to bring this back to none, and we will choose a blank. There we go. Now our minimum allocation is 20. Our max is 30%. We're doing a test split of 30. So we're saying 30% of the capital is allocated to QQQM. However, because we can only purchase whole number of shares, that represents 21% of the total money to invest in. Not because 30% would be 300, but we don't have enough money to purchase the extra share. So we're only using $209. And we're left with 790 after the first ETF. Okay, we're looking like we're in good shape so far. Okay, we'll copy these formulas down. Oh, and we have some error messages here. So let's copy this, bring it down. There we go. Okay, current price, number one, we have an error message, look for field. So let's change this. Say if error, and we'll just leave it blank. Let's copy that down. Great. Okay, now for the next ones, we have to do a little more cleanup. The first one will be on the units, because we also have an error message here for value. So let's change the units to if error. We'll add the if error, sorry, to the truncate. So we'll truncate. If that results in an error, we'll also put in blank. Let's copy that all the way down. Okay, and now for the market value, we'll do the same thing. If error, if this results in an error, then we'll put in 0. Copy it down. So we'll just do a couple of totals here at the bottom. We'll do an auto sum of our actual split. And now we'll do it for our test split as well too. I know, don't worry, it's kind of crazy. That's fine. And now the market value, we'll add this up. And for the funds remaining, we want the number here, the last number, to appear in cell B4. So we're going to use the formula we just used recently, equals take. Open bracket. What's the array? Well, between these cells here, and I'll lock it in with an F4, comma, and I'll choose -1. So it's going to find the last as opposed to the first row. Close bracket. So we have $790.20 left over. So this is the number we want to minimize. We want to make sure that's as small as possible. I'm going to apply a little bit of formatting here before we go on. I'm just going to make it look nicer and a little more fun. Give me one moment. We'll be right back. Okay, just jazzed it up a little bit. Nothing special here. I'm going to just do some fill colors here as well too. Okay. Well, the test split, these are the numbers we're going to be clearing each time that we use Solver. So I'll highlight those as well. Then a light bold here. I'll start off from the core holding. We'll purchase some symbols. Let's start off with SPLG. The price is $70. That sounds good. We'll do a dividend. Which dividend should we choose? Let's do a SCHD, pretty popular. And finally, growth. And for the growth, we'll choose QQQM. All right, so we have 3 funds that are 3-category portfolio. And now we need to optimize this. What we could do is just play around with this. Let's say we put this as 50%, we did 25 and 25, just doing it manually. Oh, and we'll get rid of all of these as well. Okay, so we're left at a total 100%. If we did the splits this way, we'd be able to use 94% of the $1,000. And that's again because of the fact that we can only purchase whole units. We want to do a better job of that. What else could we do? Well, if we have $57 left over. We know we can purchase at least another SCHD. So if I brought that up to 27%, I'll play around with it. There we go, now I have $28 left over. So I just optimized it. This is what we want Solver to do, or the file for us to do automatically. You notice the test split, we're at 102%. However, we're only using 97% of our actual funds. So the next part is using Solver. So if you don't have it, so if I go to Data, you'll notice here on the right-hand side under Analyze, I have Solver. If by any chance you don't have it, you'll have to add it in. I'll show you how to do that. We'll go to File, we'll go to Options, and from the options, we'll go to Add-ins. And from the Excel app down to the bottom, Manage Excel Add-ins, we'll go. And from here, make sure your Solver add-in is checked. We'll hit OK, and it installs Solver, and you'll be able to have access to it. Now, Solver is great for working on complex problems to find optimal solutions. That's exactly what it does. So we're going to begin. I'll click on Solver, and it asks us, set objective. What's our set objective? So remember at the beginning we said we want to minimize the amount of funds that are remaining from what we want to invest in. So on the up arrow, I'll click onto the cell here in B4, which is the funds remaining, and I want to minimize that. And so what variables, what are the variable cells we can change? Well, those are the cells in blue. So from the up arrow, I'll select these cells. These are the ones that can be changed. Now we have constraints. So the first constraint is that the funds remaining has to be greater than or equal to 0. Hit OK. If it's hit OK, then you'll notice that the constraint is in their list right here. Now we can add the next one. Now we're going to deal with the actual splits. Compare that against the minimum allocation and the maximum allocation. So the actual splits has to be less than or equal to the max constraint. Instead of hitting OK, I'm going to choose Add. Now I'll do the same thing. The actual splits have to be greater than or equal to the minimum allocation. Hit OK. Let's just review. All right, so we have our first 3 constraints. In order for this to work, we also have a few more that we have to include. We have to now include the test split as well. So add. So the test splits have to be less than or equal to the maximum allocation. And the test splits have to be greater than or equal to the minimum allocation. Hit OK. And now we come to the point of understanding which solving method that we have to choose. It defaults to GRG nonlinear. Let's just take a quick moment to understand what the different methods are. We have GRG nonlinear, simplex LP, as well as evolutionary. So which one do we choose? The first is something called GRG nonlinear, which stands for generalized reduced gradient. It's a method that Excel uses to solve complex problems when relationships between variables aren't straight lines. And this makes it more difficult to be solved. So it helps try and find the best solution when things don't follow a simple pattern, and it stops when it finds the first maximum or minimum that's going to be found. But we can change this within the options to make it work a little bit harder to find a more accurate solution. The next one is called simplex LP. So this is best when we have linear problems with continuous variables, and this method of solving goes very quickly. And the last one is evolutionary. This uses a trial and error technique to find solutions for complex nonlinear and non-smooth problems. Think of the difference between GRG nonlinear and evolutionary, as GRG finds a pretty good quote-unquote local solution, An evolutionary works harder and goes through all the solutions, and it picks the best, but it can take a much longer time to find that solution. That's why in these pictures here, I've shown the exact same line between GRG nonlinear and evolutionary, whereas on GRG nonlinear, once it finds that maximum or minimum, it stops. However, evolutionary looks at all the possible solutions. So we've set everything up here. We played around with the splits, getting pretty close, 97% efficiency on the amount that we've invested. Let's go to Solver. Now we have different models here, defaults to GRG nonlinear, and if we try clicking on this, let's see what happens here. Solver found a solution. Well, nothing's changed because we actually had our splits here. So let's clear that. Let's try it again. Solver, GRG nonlinear. So the solver could not find a feasible solution. Do you remember with the type of solving methods, it finds a localized minimum and maximum and it just stops. Well, we can push it a little bit farther. What we can do, go to Solver. Under the options, for your GRG nonlinear, we can choose multi-start. We hit OK. Now let's try solving it. And we can see in the bottom of the screen, it's currently going through the different subproblems. Converged into a probability of a good global solution. So again, a probability of a global solution. So now we're at 98.4. So it is an improvement. We have fewer funds left over. So now the methodology that I want to use, we'll go to Solver, and we're looking at evolutionary. Now, evolutionary, it takes longer to complete this. However, we're more likely to find an exact solution. So let's solve. And now it's running at the bottom. We can see that $16.37 is, since it's the incumbent, it's going to try to find a solution to seek it closer. And it hasn't. So $16.37 is the most efficient use of it. So we have the total number of units. We're actually going to just change this to 0 decimal places in terms of view. There we are. Okay, so let's try playing around with this a little bit more. So QQQM, the value is $209. I'm going to find a cheaper ETF, SCHG, $27.79. Great. Now let's use Solver to find what the optimal split is. Cleared that, we'll go to Data, Solve, and now we'll hit Solve again. Just take a few moments.
A few moments later.
And it says Solver cannot improve the current solutions. Great, then we have a lot of confidence that this is the best that we can do. Now we know exactly how many units that we have to purchase in order to maximize our funds to make sure we don't have any lazy money. So now we'll just do the final touches of cleaning this up a little bit, as well as putting some instructions to use in the future. So I'll just symbol name, I'll just widen this a little bit. Great, I'll make this row. I'll bold it, wonderful. And I'll just put the instructions just below. Okay, let's play around with this a little bit more. Let's make it a little more complex. So for the core holdings, we'll do another core holding, and we'll choose the ETF. How about IVV? 600. What's the current price? $605. That's an expensive one. Let's see if we can find one a little bit cheaper. XLG. There we go. $79. It's great, and I'm saying less expensive given the amount of money that we have to invest in. Now, which ones we actually choose? If that's something that you want me to go into, let me know, and I'll create a video on that. Dividend, and let's choose SCHD. Do another dividend. And we'll do FDVV, and finally for the growth, we'll do 2 growths. And we'll choose SCHG And what else? Perfect. It's fine. Oh, market value. Let me open. There we go. Make this a little bit bigger. Funds remaining. Okay. So based on this, we know that we don't have enough money to be able to adequately hit the splits between the minimum allocation and the maximum allocation. So let me just change this number to 5,000. We're just playing around here. Okay, we'll delete the test splits. We're starting fresh. Now we have $5,000 of funds remaining. Let's see what we come up with. Solver. And this will take a little bit of time.
A few minutes later.
Okay, we have an answer. Solver cannot improve the current solution. Okay, great. So we're able to figure it out. We have out of 5,000, based on purchasing these number of units, we would have 45 cents left over. I would say did a pretty good job in making sure that our money is working hard for us and we don't have any lazy money. There's one last enhancement that I would like to make to this model. And I know the video has gone on for way too long. It's crazy. However, I think that by doing this enhancement, it'll save a lot of frustration when Solver tells you that it can't come up with an adequate solution because the constraints haven't been met. Let me show you. If we take a look at this, I've changed out the different assets. The first one is IVV. Look at the current price here in column J. The price is currently at $606.88. Now, because we've chosen two ETFs within core holdings, we've chosen two categories, that the min allocation and the max allocation, those percentages have been divided by 2. They've been split in this case because we have 2. If we had 3 core holdings, it will be divided by 3. All right, so let's take a look at this. We have $1,000 we'll invest today, and the max allocation for this one ETF is 30%. That means the most we could put for this ETF is $300. But look at the share price. It's currently at $606. It's more than double. So if we didn't notice this, we run Solver, Solver is not going to be able to solve it for us. So let's put in a visual check that if the share price is too expensive, we know that given the amount of that we're going to invest today, we'll have to choose a cheaper ETF. So we'll go to conditional formatting, go to new rule, and from here, select a rule type. Let's go to use a formula to determine which cells to format. We're going to use an AND formula because there's 2 conditions that have to be met. Equals AND. The first condition is that the max allocation, so here in cell G7, cannot equal 0, comma. The next one, that the current price, so in cell G7, if it's greater than the amount that we're investing in today, so say B3, and apply the F4 of that to lock it in for absolute referencing, multiplied by the max allocation, so which is 30%, G7. Close bracket. Let's change the format. So for the font color, we'll make it bold, and we'll choose a dark red. And for the fill, we'll do more colors. And we'll choose a red as well. And we'll just make it a bit of a lighter red. Hit OK. That stands out. We'll hit OK. Let's apply it to the first one. Let's just copy it down. And now the ETFs with a share price that's greater than the max allocation amount, given the amount we can invest in today, are all highlighted. So let's go ahead. Let's change IVV. Let's change it to, let's try XLG. Now the formatting is gone. It's saying that the max allocation amount is suitable for the current share price. Well, thanks for hanging out. I know this is a marathon video, but we learned a lot of great functions here, including more complex topics such as Solver. Again, not a difficult tool, and very, very powerful. And this is a great application in terms of learning how to use it. All right, we'll see you in the next one.